Good morning, and I appreciate the opportunity to come here today and speak about acoustic telemetry in the Great Lakes. Talk for this audience at a little bit of an overview of the type of technology that this represents, what the challenges are in starting a new project using this technology, and what the opportunities may exist within Thoughtless to help you with that. Lots of people have helped me learn along the way, and noted here in the line: Chris Holbrook, Tom Binder, Todd Hayden, Daryl Hondorp, Chris Vandergoot, and Nancy Nate, represented by the agencies shown there. Lots of people are intimately now involved in the Great Lakes acoustic telemetry observing system, represented here by these agencies and organizations, and includes funding as well as people and boats and trucks and time on the water. So it's been a great program to be involved in. What is acoustic telemetry? In its simplest form, if you put a tag, an acoustic tag in a fish, and you set it up to ping, say every 2 minutes or every 4 minutes, and that fish happens to swim by a receiver, the receiver will record that ping, and that fish has a unique identifying acoustic signal unique to that fish. And then the receiver records that, and it adds a date and time stamp, and then you know where the receiver is. And so that's sort of the most basic sort of description. Acoustic tags, they come in various shapes and sizes. This is sort of a medium-sized tag. This is a product from Vemco, a V9. You see there's two V9s. One's just your standard tag that gives out the acoustic signal unique to the fish, but you can add other things to these tags, such as a pressure sensor. So if you have a pressure sensor tag, a V9P, when the fish swims by, it will not only give the unique identifying acoustic signal for that individual fish, but also send out what depth that fish is traveling at. You can set those tags up to last about 100 days. This is the much larger V16. It's the type of tag we put in mature walleyes or lake sturgeon, or you could put them in lake trout. If you set that tag up to ping every 2 minutes, that tag will last 10 years. Tag implantation is simple. It's an incision in the abdomen, in this case a lake sturgeon. Tag is simply pushed in, 3 sutures put into the around the incision. Fish is then removed and immediately placed into the water for release. The other side of that, of course, are receivers. Where do you place your receivers and how do you deploy them? So you can have a receivers as a line across a bay, sort of like a gate, or across an entire lake, dividing the lake in half, or placed up in tributaries. And then when the fish swims by and that tag is within detection distance of a receiver, the receiver records then that unique ID number, and again with a date and time stamp. So it allows you to get after questions such as, when or where do the fish go? When do they move? Because you have a time element to it. How do they move? What sort of path they might take? And if you associate with other environmental parameters, why do they move? So I mentioned putting receivers out in lines. That gives you really a one-dimensional viewpoint of where the fish are. But you can also put them out in arrays. And this would be where you would have a large set of receivers out, all somewhat within detection range of each other, such that when a fish swims into an array, and if you have your receivers, their clocks perfectly synchronized, you can look at then the differences in the date time stamp when a particular ping was detected, and do some math and come up with a two-dimensional position. So what types of questions can be asked with this technology? If we're thinking from a management standpoint, the first thing that came to my mind was hatchery evaluations. You could tag hatchery fish and wild fish and ask whether or not they behave differently, say during spawning or during non-spawning seasons. There's some new tags just out now that will tell you when a fish has been eaten. So if you have a small lake trout, say, that's been tagged with one of these new predation tags, you can release that, and if that fish is eaten by, say, another lake trout or a Chinook salmon, the tag will emit a different type of signal that will indicate that it is now in the stomach of a fish. Harvest management, you can get a direct estimate of what populations contribute to harvest. It's a direct mixed stock analysis. Invasive species, we have some projects on grass carp now, and we've had them on, I have them on sea lamprey, but you can ask questions such as which streams are used for spawning, or what stream channels are used for migration, and this might lead you to a management strategy of trapping for control. Population dynamics are some of the foundations of fishery management. The tags give you a capture, recapture type data, and you can calculate their annual survival rate. Population ecology asks, again, the classic question, is there more than one population that's contributing to a fishery within a body of water? Recruitment issues such as where do fish spawn, and that has to be combined with some other methods such as scuba to look for eggs or egg mats. Do fish return to sites of previous spawning? This would be spawning site fidelity. What is the timing of post-spawning movements? We've particularly gotten into that with walleyes in Lake Huron. And are those movement patterns different by stock, sex, and age? One of the unique things about this type of data is that you get repeated observations on an individual. So you can ask questions like, does more than one post-spawning life history strategy exist within the same population? And does an individual show the same post-spawning movement pattern from year to year? And that's something that we've seen in Saginaw Bay and the Tittabawassee River in Lake Huron. So what's the differences between acoustic tags and traditional tagging? So like anchors or coated wire tagging or jaw tags. Certainly without those traditional tagging methods, tagging can be very rapid, and acoustic tags take 4 to 5 minutes to do those surgeries. Tag recovery is an essential part of a project, is dependent usually in traditional tagging methods on fishery harvest or some type of agency assessment. Whereas with acoustic tags, tag recoveries are automated. It does require receiver deployment and retrieval. Probably the biggest issue is tag recovery effort in traditional tagging. If it's on agency assessment or fishery harvest, it's variable over space and time, and that's a major challenge. In this case, with acoustic tags, however, tag recovery effort can be controlled in space and time 24/7, and by putting sentinel tags out adjacent to your receivers, you can measure then the detection probability of your receiver lines. Observations with conventional tags are typically only at the time of tagging and at their recapture, but with acoustic telemetry, you get repeated observations of the same individuals over space and time. Several of our projects have thousands of observations per tag or per fish. Shedding can be higher for something like anchor tags, not true for coated wire tags. With acoustic tags, we show a very low loss of tags, very rare. Cost is a really tough one to get after. Sort of on the surface, certainly anchor tags are, say, less cost, but then coated wire tags, if you have auto fish mark trailers, they're pretty expensive. But maybe against anchor tags, acoustic tags might be 100 times more expensive. Well, what are the challenges of doing acoustic telemetry projects? Say you were interested in getting involved in that. Certainly for me, it was a major leap to do some learning and to also gain some experience. Surgeries, receiver deployments, data analysis are all challenges. If you had a new project, you might ask yourself, how can I tap others who have knowledge and experience? There's that upfront expense, we talked about that, receivers. Interestingly, some like an Ohio DNR believe and argue that more's been learned in 3 years with acoustic tags than in 20 years of traditional jaw tagging on walleyes. So if you start thinking of it in that way, then the expenses in 3 years versus the total costs over 20 years, you have to sort of amortize that out. But regardless, how can you reduce costs is another important question for a new project. Tag detections, your tags are going to be detected by other projects, and your receivers are going to have detections from other projects. So how can you move those tag detections efficiently among projects? Get your tag detections back from others and send ones out to others. Data management and analysis, all of our projects each have millions of detections. This is data management at a scope and scale that I was completely unfamiliar with. For example, in our Lake Sturgeon project in the Huron Erie corridor, the median detections per sturgeon is at 2,600, and with a maximum of 113,000 detections for one fish. This is massive. How do you manage those data? How do you filter the data? How to analyze those data? Those are all big questions that sometimes new project investigators really haven't considered. So what is GLOTTLS? Maybe this organization can help with those questions. GLOTTLS is a network of researchers that has gathered over the last 6-7 years. Uses this technology to study fish movement. Specifically, its purpose is to help develop partnerships among the projects and to share fish detection data. We are a member of the Ocean Tracking Network. It's housed in Dalhousie University in Nova Scotia, and we are their Great Lakes node, and OTN is a global network, mostly using acoustic telemetry. So let's get back to those questions. If you had a new project, how can I tap others? Well, GLOTTLS has a network of researchers with extensive experience now, and they're available to help. It ranges from just consultation to actually being co-investigators on projects or to serving on graduate student committees. What about those costs? How can I reduce my costs? Well, GLOTTLS has purchased receivers, and they're deployed Lake Ontario, Erie, Huron. We have some plans now to expand to Lake Michigan, maybe Lake Superior in the next year. Typically, project budgets, if they're developed with us, they cover the costs for the tags and for the field work, and as much as we can, we try to help with the receivers. We also have a discount arrangement with VEMCO, and so that can help reduce your costs too. Tag detections, how can you move those tag detections back and forth amongst the projects? GLOTTLS manages a basin-wide database of receiver locations and tag detections that can then be queried for your tagged fish. What about that data management issue? It's an enormous database. Again, we have researchers now that have extensive experience in managing these databases. We hope soon to have a library of R scripts up on our website to deal with sort of the common data management functions and analyses. Current status, registered within GLOTTLS, we have 107 researchers representing 35 projects, 32 species in the database, been tagged, more than 5,000 fish released, 4,346 receiver deployments at 1,600 receiver stations, represented by this map. You can see that Lake Superior is a little bit absent, but I think things are going to be happening there soon. In terms of tag detections in the database, we have 168 million total tag detections, but recall that I mentioned the Sentinel tags. So everyone puts out Sentinel tags to be able to measure that detection probability of the receivers. If you strip those out of the database, we have 97 million tag detections matched to fish IDs. So what's the benefit of being involved in GLOTTLS? Well, one of the things that's been for me that's just great has been the spirit of collaboration and cooperation. It's just a great bunch of people to work with. It's unprecedented in my experience as a researcher to see researchers from different projects helping each other in such a great way. It does provide coordination of projects. It helps to optimize our resources like receivers. And it also helps in that coordination to provide that any single new project doesn't interfere with the objectives of others that are ongoing. Study design assistance, being a part, try to help people with developing good hypothesis-driven study designs, clearly articulated research objectives. So you can make sure that it isn't just about where a fish goes on a particular day, but you get to be able to answer specific questions and such that it can be applied and we can learn and apply them to policy and management. Data sharing is flexible and easy. The receiver locations and detections are uploaded by you as they become available. You maintain control over who can access detections of your tagged fish. And Dr. Nancy Nate's in the audience here. I saw her someplace here. And she's available. She's our data manager, available to help. It also allows you to leverage then the power of the entire GLaDOS network to expand the geographic scope of your project. You can query for your tagged fish across the entire GLaDOS network of receivers and provide those results back to you as a standard export. We have an annual meeting. It's a great time to discuss new project designs, make presentations on ongoing projects or completed projects, and then meet those investigators from around the basin. What about the cost? Is there a cost to being a part of GLaDOS? Now, the cost is nothing. All you have to do is register, and with that, you also can access a VEMCO discount. So in summary, type of topics with acoustic telemetry you can go after is hatchery evaluations, invasive species movements, population ecology and dynamics, stock contributions to harvest, and individual behavior patterns. The information you get from acoustic telemetry is a little different from traditional tagging methods because you get those repeated observations on individual fish, potentially over very broad spatial and temporal scales. And it is possible to set up projects to provide a two-dimensional or fine-scale information. There are some challenges to it. Learning certainly has been one, and those large data sets provide unique issues associated with data sharing, management, and analysis. Last, GLaDOS is a network of researchers available to you, and we're happy to assist. So I'd be pleased to answer any questions if you have any. Thank you.